For my second problem, I was given number 40, which is essentially asking me to prove the coefficient of performance of a Carnot refrigerator. So to essentially prove this equation here, this one is very math based, so we will be skipping over a bit of the kind of rearranging and plug and chugs essentially. So the first thing that we want to do is essentially take the two equations that were going to be needed for this equation, which is going to be the difference of heat energy. So keep this equation in mind because we're going to be plugging that in. And the same thing with this one here. And this equation is basically the rate of heat energy absorbed. So the first step that we want is to find the efficiency of the heat engine. So we're going to be starting off with this equation here. Now, going back to the difference of heat energy, we're actually going to be plugging this in for our W. And again, when you factor everything, you're essentially going to be getting this. So earlier we kind of calculated or mentioned the rate of energy heat absorbed. So it looks similar to this, doesn't it? Well, we can actually set them equal to each other. And again, using a bit of math here, we can rearrange it to kind of make it look like this. And from here, we're going to be taking the ratio of the heat taken in from the body and the work needed to run the refrigerator, which will be giving us this here. Okay, the difference here again. And rearranging. Now from here, we move on over to this step here, and a bit of algebra manipulation again. One more time. And then essentially, if you manage to factor everything correctly and manipulate the equation, this will be our given answer, which is essentially what we were looking to prove.